A semiconductor chip is one of the most complex products ever manufactured by humankind. If that's true, then semiconductor fab is one of the most sophisticated engineering marvels ever built. So, what does it take to create one? Let's hear from our expert, John Sandeep. John Sandeep is Head of Design Operations at Fab DF1 Dholera for Tata Semiconductor Manufacturing Private Limited. He has 21 years of experience and he has led majority of infrastructure projects. With that, I extend a very warm welcome to you, sir. Please join us on the stage. I request Alok Das to present the sample.
By now, most of you would have realized that I am the odd man out here in the crowd as a civil engineer. You have been hearing about nanometers and I am going to be talking about in kilometers. As L&T, we are 34 billion USD and our market cap of 61 billion USD. And we are into a very high spectrum of things. We are into IT engineering, high-end design. We have got L&T Semiconductor with another end of the spectrum. I am from the EPC, more into infrastructure development. We have got L&T EduTech also here with us. So I don't want to take much of time. And of course, as I told, I'll be discussing about things in kilometers, so I'm just showing you the team which I am personally attached with has designed and built of this infrastructure. So this would be the flow of presentation. There are 8 key topics I thought I would share here. I'm not going to discuss about general building works. I'll focus more on what is more important and what is unique in a fab construction. Process in fab and OSAT, I'll skip. You have heard lots from the expert, and I'll just skip that. So this is a typical fab cross section. I think before we move on, I would want your attention and understanding that what a typical fab looks like, right? So the ground floor we call L10, L20, L30. So that's the different levels that we call. L10 is basically utility generation and storage. For example, we have ultra pure water, gas, chemicals, wastewater collections. So L10, so that's what's mentioned there as basement is where all of the utilities for fab is generated or it is stored. Then we move on to the next level. We call it as clean subfab. That means that that's exactly below the tool area where the distribution of all utilities happen, right? A typical fab is about 400 meters long, 150 meters wide. So a generation would be in one end of the plant in L10 that might have to go to another end, right? So that distribution completely happens in L20 and we call it clean subfab. Why we call it clean subfab? Let's pause. We'll go to one level higher, which is the tool room. All the equipments which has been discussed in the morning sessions is placed in this clean tool room. And for a 50,000 wafer per month, area of this is 32,000 square meters. You need to switch off your units. You need to be careful with the units what I'm talking. It's not square feet, it's square meters. 32,000 square meters, clean ballroom of ISO 3 particles per cubic feet, right? And that's the main fab where all the tools are going to sit in. So that's, and what you see on the left, makeup air unit. So there is going to be lot of air needs to be recirculated and lot of air needs to be added in. So to keep the place clean. And we are talking about 2 nanometer fab, 28 nanometer is the one that is being currently built in Dholera by Tata Electronics. So we have one particle getting into the gate that's going to contaminate the chip, right? The yield that has been discussed, if the yield comes down, the profitability goes down. So from now on, we are going to more focus on purity and ultra high purity of all things. So what happens here, okay, I have a separate session for HVAC also, so keep this in mind. This is something to be related to all throughout the discussion. And on the either ends, you would have a lot of scrubbers because there are lots and lots of toxic gases that's going to get generated, which needs to be safely disposed, right? Process exhaust needs to be taken care. There are a lot of toxic chemicals that's going to be generated, which needs to be disposed. And of course, there are certain things as water demand, we would be reusing certain things also. That's an isometric view of what it is, L10, we have got the generation and storage of utilities. L20 is the clean subfab, where the distribution happen, where the cabinets are to send utilities in a very precise manner, in the right concentration and in the right flow, right? That's the key. We are talking about 4,000 crore equipment, these utilities are going to go in. If one utility goes swapped, the equipment is gone. So usually the tool hookup is always taken by the customer because that's a very specialized thing, right? As a general contractor, it's not usually done. So you see the green floor, that's L30, and that is where all the tools are going to sit. For a bay, say for usually the fab bays are in multiples of 1.2 meters. The reason is this, because every 600 mm you have a 450 dia hole in the slab. If you are used to industrial structures, there would be certain cutouts that would be provided for the utilities to go. But here the thing is, every 600 mm there is a 450 dia hole. So this slab is full of holes, right? Each grid says 7.2 meters by 7.2 meters, you have 100 holes going through. Why? Certain tools could have as high as 180 utilities connecting to the tool. I'm talking about 180 different types of utilities connecting to the tool. So we will have to make that happen. So the place is full of holes. And this also acts as a plenum or a shaft for the air to flow from L30 to L20. That is why I say L20 is a clean subfab. L30 is ISO 3 particles per cubic feet. This is ISO 4 particles per cubic feet. And particles are in microns, right? So these two slides you need to have to register it well. So L30, the very important thing is, all the other structural system of fab is a typical structural system that you would see in any construction. L30 is a very critical one. The primary reason is vibration, right? You have a lithography machine, and you are talking about 2 nanometers, 20 nanometers. I cannot afford that floor to move 2 nanometer, right? So that is the vibration. We call it, in litho area it is VCD plus, other places it is VCD and VCC. That's the category of vibration. I don't want to get more into it. Just to give you an idea, it is not about earthquake vibration. We are talking about somebody walking next to it is a vibration, right? Highway close to this fab is a vibration. In Taiwan, I come to understand that high-speed rail was diverted from Hsinchu because there were so many fab plants and that was not designed for this vibration. High-speed rail diverted for 20-30 kilometers away. So that is the vibration that we are talking about. Yeah. So how do we achieve it? As I told, you should have a lot of holes and vibration needs to be taken care. So there are two types of slab. One is waffle slab and cheese slab. Typically same, you have got full holes across. From top, you look at, it looks the same. But from bottom, if you look at, you will have a scoop out and then you will have these holes. So this, we call it as waffle slab. Cheese slab is from top and bottom, it looks the same, but you have got every 600 mm, you have got 450 dia holes. So how do you pour concrete for that? You either have a left in place FRP shutter, and then sometimes we have left in place stainless steel because FRP is a fire hazard, and some insurance agencies, they don't agree for FRP to be left in there because that's a fire hazard. So one structural component which would scream out to be very different is the cheese and waffle slab. We'll step back and move to clean room. That's a typical false ceiling of a clean room. Everything gets integrated in the clean room false ceiling. It needs to be clean, right? You see the light getting integrated there. Sprinkler you would not be able to see because that gets recessed and that gets there. You've got a lot of gas detection system that goes up there. We are talking about a lot of hazardous gas chemicals. So just a view of how these clean room false ceiling would look like. And that's a very typical detail of what it is, because in this false ceiling you will have automated handling system. In the the ballroom, the clean fab area of 32,000 square meters, you will have very little people going there because a person going in and coming out is a source of contamination, right? And you will have to be fully like bunny suit up, you will have to go in. And so there are special clamps where this automation, it is like it uses vacuum, it picks up the wafer from one machine to other machine, and all these happen. So that gets integrated with the false ceiling. And again, we need to be mindful of vibration. Anything you do, it's again vibration, vibration, and vibration. It's actually micro vibration, it's not vibration. So, and all of the floor has a raised metal floor, right? 1.2 meter high raised metal floor where the tools would sit and where people will move. And this needs to take about 2 tons per square meter load. This should be taking. Usually a multi-level car park or a driveway is about 500 kg per square meter. So it is 4 times higher minimum of the floor load that it should be able to take. So these are also like false ceiling panels, some are solid blocks, some are perforated. That is based on the airflow that is required to go below to L10 clean subfab. So you have this on the right bottom, you will see that is how it is going to be. And when the tool installation happens, people will be crawling inside this, pulling up utilities to hook up to the tools. Right bottom is a very good example of how it's going to look like when things happen. And all the panels are, this is actually a room inside a building, right? This is an exclusive room inside the building, so that is all built up with honeycomb, aluminum honeycomb panels. It's like, for rigidity, it's like a honeycomb. It's aluminum honeycomb panels, which typically makes the walls and ceilings. On the right, that is how a fab without tool installation would look like, right? It's going to be about 350-400 meters longer than a football ground. A football ground is 200 meters. And this is about clean room, and then you will have lot of concrete that is to be protected, right? Concrete generates dust, and I cannot afford to have a dust, so there are a lot of special coatings that is required to coat, and especially in L30, this needs to be corrosion resistant coating. There is a special coating that needs to be done because there are certain chemicals. If there is a leak, if it falls in concrete, it is just going to eat through the concrete and keep going down. So I would say that is about civil structure, architectural part of a fab. Moving on to HVAC, which is a very important part. Usually there are 2 types of chillers that is used. Low temperature chiller and medium temperature chiller. Medium temperature chiller, usually the temperature samples is 13 degree and 20 degree. So the inlet temperature of the chiller would be 20 and outlet temperature would be 13. And for the low temperature, the inlet will be 13 and outlet will be 14. So that's the cooling delta. This is for the efficiency. And just to give you an idea, the amount in that one small building, I think that's the highest in the country. To compare it with airport cooling, it is about 10 times more than airport cooling. I'm talking about Delhi, Mumbai airport size of cooling requirement in a fan. So we have 2 different loops, a low temperature and medium temperature chiller. It meets for pre-cooling, dry coil units, process cooling for the compressed air and other things, that is for the medium, and low temperature chiller is mostly for, you need to have the air coming in to be highly dry. You cannot have moisture. So to remove the moisture from the air, we use this cooling loops. And of course, we would have a cooling tower for these chillers. and lot of water is going to be used, so recycled water and of course fresh water will also be used. As in any cooling tower, we would have chemical dosing system to avoid any algae formation or bacterial build-up in the cooling water. There is always a special glycol chiller that's minus 16 degrees to minus 20 degrees. This glycol chiller is used for cooling of tools. This is mostly dedicated for the tool cooling. We are talking about minus 16 and minus 20 degrees Celsius. That's a very typical of HVAC. You see the clean room. So from top we have the air pushed in through the false ceiling through fan filter units. On the right, what you see is fan filter units. So each would have HEPA filter and higher, so that all the particles get filtered out. So, and for the cooling of the area, we have dry cooling coils. It is like an indoor AC unit without a airflow, right? Just like our old fridges, where ice gets formed. So that's a typical dry cooling coil. Ice would not get formed here because it is already dehumidified. You could ask me that question. Are you going to clean the ice? No, that will be dehumidified, so we would not have ice forming here. And of course, air handling units, low temperature and medium temperature chiller. On the left, we have the makeup air units, and the makeup air units is where the external air is used for the makeup of air, because we'll have good amount of air lost out through leakages, and this will require special filtration based on locations, right? We have scrubbers next to the fab itself. Our own scrubbers could contaminate our makeup air unit, so we should have a lot of chemical filters. A lot of study goes into what kind of filtration is required in makeup air units based on the locality, right? So that's about the HVAC process exhaust. This is a very important one. If this process exhaust doesn't work, you could easily see birds just falling up when it flies through the fab, right? That's the first indication. So that is the toxic gases that we are dealing up. This needs to be dealt before we let it out. So base exhaust fan, it is, if the fumes are base, then we dose it with acid to neutralize it, and then we exhaust. If it is acid, on the right you see acid exhaust. If it is an acidic fume, then we dose it with a base to neutralize and exhaust it. Then there are solvent exhausts, right? So these solvent needs to be burnt before we exhaust it. So we would have natural gas burning this before we exhaust, because we cannot afford to exhaust it as such. There is CVD exhaust, where the dust, the toxic dust needs to be filtered and then exhausted. So these are the typical process exhausts. We'll move on to the most important of the fab, that is ultra pure water and wastewater treatment. So just to give you a perspective, the water that we drink, the TDS, everybody should be aware because we have got at least a RO system at home. So TDS is about 100 ppm, right? Here the TDS is less than 1 ppb, parts per billion. And the particle size that we are talking about is about 5 microns in normal water. And here the particle size, what we are talking out is 0.05 microns to 1 micron. So the particle size is less, and TDS that is allowed is less than 1 parts per billion. right? And how do you measure whether it is within the allowable TDS or not? There is no way you can measure. Only way to measure is to look at the resistivity of water. So we are talking about greater than 18.2 mega ohms. The water is not going to have any conductivity because the impurity in water is actually what leads to the conductivity of water, electric conductivity of water. So based on resistivity is what they check, okay, this is fine to get inside. So we have got a lot of filtration process. One process before UPW is DI water. Most of the industries we use demineralized and DI water. So that is one process. So what happens on the supply? You have ultra pure water in the supply that goes to the tools, and then this water is not thrown out. This goes back to DI tank. If I go back, you see DI water tank. So you see a green loop that is going there. So that's POD is the tools basically. So from that it goes to DI, and then this gets, we call it polishing. It's not filtration. For UPW we call it polishing. Right? This is on UPW, just to give you a glimpse. And on WWT, we will have to treat these waters, right? There are a lot of effluent that is going to come from tools, effluent from cooling tower. We have WT, that is RO rejects. All these effluents are treated. Some can be used back and some has to be disposed of. So that's the wastewater treatment that's happening. This is a very big system in any fab, because if we don't have this, the water requirements could be 3 times higher than what is being currently being used. Gas systems, that's the next topic. There are 2 bulk gases, right? Nitrogen, oxygen, argon, helium, carbon dioxide, hydrogen. And all of these gases are dealt in 2 different grades. Pure, that is general, and then it is ultra pure. Ultra pure is to 99.99969. So that is the ultra pure gas that we are dealing about. The material used for conveyance is stainless steel 316, BA, EP and EP coax. What is coax? We have 2 pipes, one pipe inside another, so that if there is a leak in the first pipe, before it could contaminate the environment, there are leak detection systems inside the second pipe. This gets triggered and then the shutdown of that stream happens. So that is why you would see this in very high hazardous chemical and gas handling systems. So bulk gases, this is a typical, you have large tanks to have, you have ASUs, air separation units, and it comes in big tanks. So it is a big yard. A very typical example is if you have gone to hospitals, you have oxygen bullet there, liquid oxygen there. So something like that, for different gases. And of course, it goes into L10 of fab, and then through distribution units, it gets distributed in very precise quantity as required in the tools. Specialty gases are very careful to be handled. It's not of bulk. We are talking of hydrogen bromide, hydrogen fluoride. Just remember this word, you can go and Google what hydrogen fluoride does. Propane, sulfur dioxide, nitric oxides. So the pipe transportation system is PTFE lined SS pipes. Because this is so corrosive, this will eat away anything that comes into contact. So it is PTFE lined stainless steel pipes, and again certain things, stainless steel pipes, electro polished with coaxial. So what happens is this system requires a lot of monitoring. It comes in small totes, gets stored next to fab, and the room is monitored for any leaks. Each gas type has a separate room. Room gets monitored for any leaks. The CDU, the distribution cabinets, gets monitored for any leaks. So there is a continuous monitoring process of any leaks because we cannot afford to have these of the gases being leaked out to environment. Chemical, so similarly we have chemical unloading and distribution system, fluoric acid, caustic, H2SO4. So these are the chemicals. Again, the piping is almost the same as for what we have seen in gases. So what happens, we have, it comes in lorry, gets in a tank stored, and then the distribution happens. This is usually in L10. So as I told you, L10 is generation or storage level, and then that gets distributed to L30. These chemicals cannot be treated. All these chemicals that goes to tools has a separate collection, and that gets tanked out. This cannot be treated in the factory or the fab. In Taiwan, what we have seen is there are municipal treatment centers for these. In India, we will have to develop this before the fab gets operational. These are very hazardous chemicals which cannot be just let out in water. It cannot be let out in dilution. Quickly go to compressed air. This is very similar to any of the industrial compressed air, but we have special filters to remove moisture. You will have little bit traces of oil, so that needs to be filtered out, and any particles. Right? This is CDA, compressed dry air. So we have centrifugal pumps, compressors, and we have screw compressors. Based on requirements, it's a mix of these for the compressed air generation. And you will see this will get linked to the cooling system because this needs to be cooled also. So we have receiving tanks, dryer receiving tanks, and then we have the final filter before it gets into the fab. We have vacuum system. Vacuum system is very important for the material handling. So each of these wafers gets lifted with a vacuum system. It's like a vacuum cleaner. You throw a cloth on a vacuum cleaner, it gets stuck, right? So that's how that is used, and that's mostly for the vacuum system. Yeah, thank you. What I have tried to cover is a specialist of things that comes in a fab construction. I have not covered on the general electrical. In fact, the electrical loads are very high. I see that could be a system that would be on any industry. Life and fire and life safety is a very other thing. But that's, it's with the special gases, yes, but other than that, it is a normal construction. Yeah. Thank you. Any questions if you have time for, or?
Such a big fab plant, what is the predictive maintenance? Primarily, such a big plant need very predictive intelligence is very much required, right, in terms of the continuous operation. So how that is taken care?
Okay, I am looking into from a construction perspective, but what I come to understand with experts is, I'll tell you, when we do the BIM for this construction, building integrated management, each of the equipment gets tagged, right? And we call it asset management. COBE asset management is done for each. It could be a sprinkler, it could be a sensor, each of this gets tagged. And each of these gets flagged on what is the maintenance that needs to be done. because we cannot have these things failing. So that gets integrated to that. That is from a building perspective. Now from an operational perspective, it is a very complicated one, and I don't think I have the right knowledge to answer that from an operation perspective.
Maybe just one more question, sorry about that. How is the material handling system? Because such a plant which need so much of cleanliness and it's critically built. How is the material handling happens?
It has an overhead conveyor kind of. You see a track. So on these tracks, these things happen. You just go to YouTube, material handling system in Fab, you search, you have enough videos on these.
Okay, thank you.
John. Just a small question. You mentioned that you are looking at micro vibrations and any small amount of vibration. So what sort of sensors have you integrated with the BIM to be able to measure them?
See, this starts from design. It's not that. So in design, the complete study of the facility is done with respect to what location it is there, what could be future highways, other airports, railway system, soil. Based on this model, what happens when the design happens, the areas are kept very rigid. So I was talking about cheese slab and waffle slab, right? In a litho area, usually the cheese slab is 1 meter thick. And in other areas, it is about 800 mm thick. So this kind of design gets into. Apart from that, there are normal vibration sensors that are placed, but those things are placed on the tools rather than on the buildings.
The reason I asked this question was, we recently had a chance to go and see the Chenab Bridge. So there they told us that they have a lot of these sensors embedded in the concrete structure to be able to measure the vibrations and be able to figure out how the bridge is doing in real time.
That is on resonance and vibration.
Right.
This is on micro vibrations. Okay. And again, on vibration, it doesn't mean that the vibration is fully taken care by the building system. Each tool has vibration isolators.
Okay.
Viscous dampers are kept in so that, these vibration do not get into those machines.
On the MEP one, since it's so complicated, would you go beyond BIM and look at maybe a digital twin on a long term?
We use a digital twin because, for an execution engineer to stand there and, look at the kind of utilities that is going to come. See, I told 180 is for one tool, that's the highest, right? And, what we do is, we do a digital twin and we load it in the cloud and we carry an iPad. And what happens is we call that, augmented reality. So if one utility needs to go there, that is shown as a utility which is yet to be constructed, and then it gets superimposed with the actual image, the feed. So I would say if none of this false ceiling is done, if I have a digital twin and load it up, when I look up, I will know what kind of false ceiling is going to come. So this happens easy to back check whether it is constructed. And the construction tolerance of utilities that we are looking in, especially in L20, where it is utility intense, we are saying 1/4 of an inch. So a pipe, what I am going to install, cannot go 6 mm away from where it has to be truly installed. If I deviate 6 mm away, then maybe for another utility I don't have space to put there. So this is what we are talking about on the construction precision.
So from your first-hand knowledge, in your opinion, how much of all of this, starting from the sand, cement, blocks, gas, clean water, equipment for making it clean, all these things, how much is imported right now?
See, I'll tell you, everything is absolutely important because...
No, not imported, imported from...
Imported, okay, sorry. With respect to civil works, I don't see any import happening. except for some special inserts, like we call it unistrut, embedded slotted channels. Those are locally available also, but there are resistance to use that because we don't want any contamination during the operation. So civil works, I don't see. Civil structural works, I don't see. With respect to architectural finishing, certain like paints and certain CRCs had to be imported, but majority is available in India. With respect to utilities, certain kinds of pipes needs to be imported. See, SS pipes, electro polished or bright annealed, these are used in the pharma industry. So these pipes are available. But certain pipes like coaxial pipes and certain material for ultra pure water, these are MEP front, especially the special utilities, the utilities which I covered, majority is being imported. For the utilities what I have covered here, majority is being imported, and in fact we don't have vendors to work on these. In fact, our vendors are from Southeast Asia, Israel, Europe, US, Japan, Taiwan. So these are the vendors that we are working with for the special packages.
So I have a follow-up question on the stainless steel pipe or coaxial pipe you are talking about. So you are importing those.
No, stainless steel pipes are
The
available.
coaxial pipes you are importing.
Coaxial
Right?
are-
So what is the lifetime for this pipe? I mean, will there be any serviceable agreement?
See, usually these are about 25 years to 30 years. So, and by that time, the manufacturing technology also moves out. So these fabs, unrefurbished, is maybe 25 years.
So you are saying until next 25 years these pipes need not be replaced or
No,
anything?
that needs to be monitored.
Monitored?
It's not that you place that and forget about it. That needs to be monitored.
Thank you.
So this ceiling blocks all are available in India or it is imported?
Which
Ceilings, the clean room.
clean room is available. Clean room panels are available, but for the magnitude what we are looking at, it's not available.
So last question I had.
Sir, can we take it?
Just a quick.
Yeah.
You mentioned that you have got vendors you had from the Southeast Asia and all of that. Over the years, how do you think some sort of transfer of technology or this will happen that when these new fabs are coming in, local people will be able to get that skills and be able to.
See, I'll tell you, most of these vendors are trying to have a local tie-up with India. Right? For example, Nomura has a tie-up with Gradient. Gradient is a local, I'll call DI water treatment vendor. He has got a tie-up with Nomura, is from Japan. So it will happen, and the world is seeing India as the opportunity for their growth. There are few clean room vendors who have come, they have started setting up in India because we know the market is going to be very high. It's not only for fab, so many OSATs are coming in, which helps for those.
Thank you, John, Sandeep, sir. It was a very different session from rest of it. The perspective behind the scenes, what goes in to accomplish one of the critical pillars in Indian semiconductor ecosystem. With that, I now call upon Vishal Shah sir to come and present memento to John Sandeep sir.